So let me have the exam next Monday. So this will give us enough time to finish a few important topics this week. Okay. So we won't postpone it after that. So for sure we'll have it next Monday. Okay. All right. So last time we were looking at interfaces. Okay, and we discussed that we can create custom interfaces, meaning we define the interface, or there are already predefined interfaces in the library, so we refer to them as standard interfaces, right? So we were looking at some of these popular interfaces, such as IClonable, IComparable, and Icomparer, and so on. Equality comparer, and there's many. Okay, so as a minimum, we should know 3-4 of these very nicely. Okay, so last time we looked at IClonable, and you guys saw that anytime you create a class, let's say XYZ. If you wanted to be able to make in-memory copy of this particular class object, then you will implement IClonable, right? C# uses the same syntax as inheritance for implementing an interface, because interfaces act as base references for all practical purposes, right? Okay, so as soon as we do this, and if you right-click on it through quick actions, implement interface, it will give you a public object clone method, right? And now you can write your code in it. Okay? So we discussed that if all the fields in your class, whatever fields you have declared, if they are basic data types, okay, meaning it could be int, double, string, right? There's no object of a class or no array over here, okay? So in that case, what kind of code do you write in the clone? You simply write one line of code, and what's that? Return this dot member-wise clone. So we discussed that member-wise clone only does shallow copying, right? So it basically assigns one field to another. So now if we have, instead of basic data types, we have also some, let's say, class object. Or we have, let's say, an array as part of the fields of our class, right? So then member-wise clone will not work. So for these types, what do we have to do? Further, we have to call the clone on it, right? So for example, our code in that case will become XYZ, let's say x1 equal to XYZ. So we'll make a shallow copy, store it in x1, for example, right? Then what do we have to do? Then you have to go one by one. Suppose this field is called address or ADDR, right? So you will say x1.addr equal to this dot addr dot clone. So what does that mean? If this was a class called address, somebody has to implement IClonable on it. So if you created it, you will implement IClonable on it, right? Further, so you'll define the same clone over here. If it's an array or a list, then or any other .NET library class, .NET library already implements IClonable for most of its classes. So for example, let's call it, let's say ARR is the name of the field over here. And suppose it's an array of doubles. If that's the case, then what will you do? You will say x1.arr equal to this dot ARR dot clone, right? But then clone always returns an object. So what should we do over here? We will typecast it to our double left square bracket, right square bracket, left paren, right paren, and then this thing will go over here, right? So, so this way we can implement the cloning properly, okay? Anyway, coming to IComparable, the purpose of the IComparable is to be able to compare two objects on a particular field. So for example, if you created a student class, okay, and you wanted to do something like this, let's say S1 is an object of the student class, okay, and you wanted to be able to compare to S2, right? So whether S1 is greater than S2, or S1 is less than S2, or S1 is equal to S2, right? So the way the compare to method is provided to us is it's part of the IComparable interface. Very similar to like the clone is part of IClonable interface, right? So very similarly, compare to is part of the IComparable interface. Okay. What does clone return? Object, right? What does compare to return? Compare to returns. Remember, there are three possibilities. Two things could be equal, right? S1 could be equal to S2, or it could be less, or it could be greater. So the way this compare to is designed is it always returns an integer. If this is 0, so what does that mean? S1 is equal to S2. If it is -1, what does that mean? S1 is less than, and +1 means S1 is greater than S2. So anytime we call compare to, you will get one of the three possible numbers, -1, 0, or 1, right? Okay. So now we can use it in comparing two simple things. We can use it in sorting as an example, right? To give you a small example, actually let me do this so that you guys can also see some of the other neat things. Let me program it on the computer. So at least it worked right away today. So anyway, so let me create a new project and store it in our fall 2015 folder, right? And let me call it, let me just call it sort application, sort app, okay? So we'll do some kind of a sorting. So I'm creating a Windows Forms application, Visual C# sort app. If I click OK. Alright, once it creates the skeleton. Okay, so now let me go first bring our student class from our previous example. So if I right click, add existing item, and go to our What was the last one we were doing?
Interfaces.
Interfaces. Okay, and let me change this to, okay, or I can leave it over here. Let me just change the name of the namespace to sort at. Okay, we already have IComparable. Okay, now one class can implement more than one interface. It's okay to implement more than one interface, right? So let me address. What happened? Oh, I also need to bring address. So add existing item address. And if I go to the address class, let me also make it the same namespace. So, sort F. Okay, so back to student, right? Let me also override the toString so that we can easily see what data we are, if we are sorting. So I will do public override, and then double click on the toString over here, and then return, let's say, first name plus last name plus id.toString plus just one toString plus test 2 dot toString. Okay, so anyway, this is our simple toString method, right? So that we can at least see what data we are looking at. So now, to implement sorting, we need to be able to compare two students. So the question is, if we compare two students, or if we sort a list of students, what do we sort on? Do we sort on first name, ID, test 1, test 2, and as you will see, that's the job of the IComparable. So if I go IComparable, so as I mentioned, one class can implement as many interfaces as we feel like it, okay? But one class can only inherit from a single other class. So if we are inheriting, the class name will always go first, if we are inheriting from another class, but then followed by a comma-separated list of as many interfaces as we want, right? Okay, so now what's the method in IComparable? Compare to, but what's the signature? Rather than us trying to remember it, simply right-click and implement interface. Implement interface. If you're using Visual Studio 2015, it will say quick actions and then implement interface, right? Okay, now if I scroll to the bottom of the class, you'll see it has already written compare to, right? So remember, as I mentioned, the way this will be called is, somebody will say, somebody has already created, let's say, an object S1 of type student. Suppose they have already created S2 of type student. Then they will do something like this. Int result equal to S1 dot compare to S2. Right? So when they call the compare to, take a look, one of the objects that we are trying to compare to will be passed as a parameter, right? The other one is being called through, meaning inside the compare to, if we wrote this keyword, what will it imply? S1. Okay, so that's why if you take a look at the signature of compare to, it only takes one parameter, whatever the second object we are comparing to. The first object will be available implicitly whenever we use the this keyword, right? So if I go over here, So our code will look something like this, okay? So int result equal to 0, because we have to return, as I mentioned, 0, 1, or -1, right? So that will be our reply. Okay, now before we can compare this object to this part over here, we need to convert it to a student object, right? Because we are writing this code in the student class, correct? Okay, so we will use the is or as operator, for example. So you could do either way. So one option is you could do student, for example, s2 equal to obj as student, correct? Now remember, the way it works is it will check, is obj a student? If it is a student, it will convert it to a student, and now we can store s2, or s2 will be pointing to it, right? What if obj is not a student? Then what will s2 be? None, right? Okay, so once we have done that, then our typical code will be check if s2 is not equal to null, right? Then return this dot compare to. Now when we use this keyword, remember we are inside the student class, so this already is the student object, right? Now which field should we sort on? This is where we need to decide. This dot. Okay, suppose we wanted to sort students by, let's say, ID. Okay, so then you will say this dot ID dot compare to s2 dot ID. So now we'll compare the two IDs, and whatever the comparison answer is, like 0, 1, -1, we'll give it to, or let me, rather than saying return, let me do res equal to, because inside an if statement, if you return, but if that if statement is not right, so that's why the compiler is still complaining that not all code paths were returning any answer, right? So for this reason, let me store it in res, and at the very end, I will do return res, okay? And as soon as I do that, you'll see this error will go away, okay? So now that we have provided a comparison of two student objects based on which field? ID, right? Okay, now we can create a list of students and call the sort method, and it will sort them by ID, okay? So the, okay, yeah, so let's do the sorting now. So let me go to the form, go to the toolbox, and double click on a button. Okay, so if we now do okay, so let me just call it btn sort, and let's say sort. Okay, now if I double click on it, okay, so what I'll do is in the very beginning of the form class, I'll create an array list of students. So array list, st list, and let me just right click on it and resolve it because it's in a namespace system.collections. So st list equal to new array list, and let me pop in the constructor of the form after the initialize component. By the way, this initialize component always creates all the buttons and text boxes and so on. So if you wanted to do any of your own initialization, do it after the initialize component call. Okay. So after this call, let me create a few students and populate them. Student s1 equal to new student. Okay, last time I showed you, even if we don't have a constructor, using curly braces, we can initialize. Okay, so once you put left curly brace, right curly brace, and just hit a space bar, it will give you all the fields.
It's like form load event?
This is the constructor. We could have done it in the form load event also. Okay, so suppose, let me put some data over here, comma. Let's say last name equal to data, comma, ID equal to, let's say, 1, 2, 3, 4, 5, comma, let's say test 1 equal to 85, and test 2 equal to, let's say, 91, okay? And then let me add it to STList. Okay, so once we add it to the STList, I'll just copy these two statements and change the data and create a couple more students. So now for the second student, okay, let me make it, let's say Sally Simpson. Let me make it 1, 2, 3, 4, 2. Suppose 88, 92, and SD.list dot add S2. And very similarly, let me add a third student. So let me make this S3, and suppose this is called, the name is Mark. Matthews, 1, 2, 3, 4, 8, let's say 82, 77. Okay, so anyway, let's pretend an S3 over here, right? So now 3 students have been added to our ST list, correct? As soon as we run the form, because all this code was written.
It should be
S1.
So that should be S1. Okay, that should be S2, that should be S3, right? Okay, so so to this ST list in the constructor of the form, we've added the 3 students, right? Now let's go to the button handler for BTN sort. So, so now the quick sort is already implemented for lists and arrays. So you don't have to write your own quick sort algorithm. Okay, all you have to do is go STList.sort. Okay, and that's how easy it is to call the sort method, right? So by the way, suppose we do not implement the Icomparable. So if I go to the student class, okay, let me just remove this Icomparable for momentarily, right? So it's okay, I can still leave the compare to over there, but I removed the Icomparable, right? So if I try to run it, okay, click on the button, okay, so you will see it generates an error message, and if we take a look at the error message, do you see something like failed to compare 2 elements, right? Because internally, the quick sort will try to do S1 dot compare to, and once it does that, it checks to see whether there's the interface Icomparable implemented. Okay, so if the class does not implement it, it simply says I don't know how to compare 2 students, therefore I cannot sort it, right? So now let me put the IComparable over there. Okay, the method is already there. Okay, but anyway, so see, this is how, as two classes interact with each other, they check before, they don't just go and say, do you have a compare to method? They check to see whether the interface IComparable is implemented. Okay, anyway, now let's print out the results. So if I right click on, if I go down, on the form code, right click, view code. So let's print out the after sorting what happened to ST list. So let me write a short code. Or let me do this. Let me write another method. Void show list. Okay, and here I can simply say string out of blank, and for each student ST in ST list, and out1 plus equal to st.toString. And let me put each one on a separate line. And message box dot show output. Right? Okay, and over here I'll just call this method after I call the sort to show the results. So show list. All right, so now let's run it. Okay, so now if I click on the button,
Icomparer.
oh, did I put Icomparer over there? We do have Icomparer.
So is there any default method which we need to implement in that?
Okay, let me see what happened. The only issue could be the address. Let me do this. Where's the address class? Let me comment it out just in case it's expecting. No, then that should not be a problem. Yeah, you did Icomparer, right? Just in case that should not be an issue, but let me see why is it complaining. Okay, the old program was running. I have to stop the old program, then run it one more time. Okay, so I think what happened is okay, first let's see, we were sorting by ID, and then we'll see why we were getting the error before. So do you see Sally Simpson has the ID 12342, right? 12345, so did it sort correctly?
Yes.
Right, okay. So now, okay, let me try to figure out, was it the address class causing the problem? So if we uncomment this one. Okay, so yeah, it must have been something else because it should not cause any problem. Yeah, most likely what happened is, let me show you why possibly we got the error. Okay, now suppose I run the program. Okay, and the program is running, right? So now suppose I click somewhere. So the old program is still running, it's minimized over here, right? So now if I make a change, for example, do something, right? And if I try to run again, it took a while, sorry, this is the old copy. See, you'll see there's, when I try to run it again, it will say there were build errors, right? If I say no, you will say could not copy because there's an already a program running called sortapp.ax, right? So that was the issue last time, most likely, because I had not closed the old copy of the program. So anyway, if you get this error, could not copy, make sure you check your taskbar, see there's no form running. And if you have stopped it and you run it again, then it should work okay, right? Okay, now let's pretend we wanted to, so first let me run it one more time. Okay, if I click over here, what field is it sorting on right now? ID, right? What if we wanted to sort by last name? In that case, what should be the output? Baker, then Matthews, then Simpson, right? Okay, so what do we have to do if we wanted to sort by last name? Where should we make the change? In the compare to, right?
Yeah.
So if I go to the student class and go look at the compare to, what will I have to do? Last name, and because we are inside the class, we can sort on the private field, correct? Okay, now let me ask you one more question. This is, we are calling the compare to over here, right? This is also compare to. So are we calling ourselves? Is it a recursive call? Okay, what type is last name? What data type is it?
String.
String. So see, this compare to is being called on the string class, okay? Whereas this compare to is being called on the student class. So no, it's not a recursive call, okay? So that's why I was saying .NET library has standardized all comparisons, so string, even the integers, doubles, any class that's written will always implement IComparable so that we can compare any two things. Okay, so the reason we did that is because what does compare to return? 0, 1, or -1. So this way our job is easy. We can ask the string class to compare two things, and whatever 0, 1, -1 we get back, we will return it for the student comparison, right? Okay, so anyway, so the change we needed to make was we needed to go to the compare to method and change from ID to the last name, correct? So now if we run it, so is it sorting by last name? Right? Now suppose somebody comes to you and says, now sort by test 1 or test 2, okay? So what will you do again? Go and change this to some other field, right? Okay, now what if this code, meaning the student class, so remember this is the student class, right? Is not developed by you. It was developed by some professional software company, and they gave you as an executable code, meaning as a library, so you don't have the source code to go and change it, okay? So then what if your project manager, if you're working for a company, your project manager says, oh, we want to sort by the last test score, can you do that? So how will you do it if you don't have the code for it? You'll probably call the company and saying, you know, my boss will be upset, please send me the updated class as soon as possible, right? Okay, so this technique works, but only if you are developing it yourself. We need a better technique so that we can pick any field to sort on. And also, we shouldn't have to go to the student class to keep changing it, recompiling it. The client, whoever is trying to call it, should be able to say, okay, now sort by this, now sort by this. without us having to modify the student class, right? So now let me introduce a better interface called Icomparer. Okay, so now let me implement Icomparer. Okay. So anyway, you will notice there's also a less than greater than sign, so there's a generic version of it. Pretty soon I will introduce generics to you, but since we haven't covered those yet, so all you have to do is right click on it and resolve it, and it will give you system.collections is where Icomparer is defined. So once you do that, it will change color, right? Okay, okay, now your typical intuition would be if we wanted to have a very flexible sorting. Typically we implement the interface on the same class where we are trying to achieve something, right? If we wanted to achieve cloning, we'll implement iClonable on the student class, right? If we wanted to be able to compare a particular field so that somebody can sort on it, we'll implement Icomparable again on the student class, right? Icomparer basically is a flexible comparison so that we can compare on any field, but unlike the other techniques, meaning implementing the interface directly on the class, okay, there's a better way to program this. So I will not implement Icomparer on the student class. Instead, I will create a new class, which will further delegate the work back to the student class. Okay? So this is a little bit advanced, but hopefully once we go through it, it will make sense. So I'll right-click on the name of the project and add a new class. Okay, and let me call it, you can call it anything you feel like it. So for example, we could call it student sort helper. Okay, so its job is to help us pick a field for whatever sorting we needed to accomplish, right? Student sort helper. And again, you can call it anything you feel like it. So over here, now I will implement Icomparer. Okay, and then delegate, sorry, I misspelled. Okay, and then delegate the work of comparison back to the student class. Anyway, let me first resolve it. Okay, so before we write the code for whatever the method is in Icomparer, what's the purpose of this class? The purpose of this class is to be able to pick a field to sort on. Okay, so let's call it string. Let me just call it sort field, or let me just call it. All right, sort field is a good name. Okay, and then I can right-click, refactor, encapsulate field. And delete the extra blank line. So again, so this could be, for example, first name, this could be last name, this could be ID. So the caller will set this field before calling the sort method. So that's the idea, right? Okay, so now let's implement the Icomparer. So if I right click on Icomparer, implement interface. So as you will see, it gives us a slightly different method. Remember, for Icomparable, it was called compare to. Here it is called compare. In both objects that we are comparing, for example, if we are comparing S1, S2, they will be passed explicitly over here. And what will it reply back as? Integer. Which will again be 0, 1, or -1, right? Okay, so what's our typical code? Okay, so this is what we'll do. First, we have to convert X to student, Y to student, right? So we will do student S1 equal to X as student, correct? Makes sense? And student S2 equal to Y as student. Okay, now we should check whether we were successful in comparing before we proceed further. And since we'll be returning a number, int result equal to 0, and now we will say if S1 is not equal to null, and S2 not equal to null, right? And then what should we do? Okay, then we need to compare S1 and S2, right? But compare on which field? ID or student, ID or first name or last name or
Sort field.
on the sort field. See, that was the whole purpose of it, that the caller will set this to either first name or last name or ID. So we have to sort it based on this, right? So now we can basically say over here result equal to S1 dot compare, or we can call it anything, compare to S2 comma sort field. So rather than us doing the comparison of ourselves over here, it's a good programming practice that because the purpose is to compare the two students, right? So that comparison should be done by the class itself, not by somebody else, okay? So we could have written the code, if, for example, sort field is last name, then do S1 dot last name dot compare to S2 dot last name. We could have written it here, all that code. But like I said, it's always a good programming practice to have somebody do their own work, right? So this would be as if somebody asked you to give you some work to do, and let's say it's in a field that somebody else specializes in, so you will delegate the work to that person, okay? Anyway, similar idea over here, so we are delegating the work of comparison to the student class itself. What method do we call doesn't matter. You can call it comparison, or you can call it compare to. Even if I call it compare to, is there a method in student class called compare to?
No.
Not of this parameter.
Exactly, not with these parameters. There is a method called compare to, but it takes only one object as a parameter. It does not take two things, right? So let me go back to, where was I? Student sort helper, right? Okay, so we need to write a method that takes a student as one parameter and a string as the second parameter in the student class, right? And then once the student class gives us the answer, then we'll return that result. So let me go to the student class now and add one more method over here, matching that signature. So what will it be? So now I'm in the student class. So public int, we called it compare to, right? And like I said, it doesn't matter, we could have called it anything. But because most of the time when we are comparing two things, compare to is the standard terminology, so I left it at that, right? What was the first parameter that we want over here? Student. What's the second parameter we want? Whatever the field name is, correct? On which we wanted to sort on. Okay, so now our work is easy. So we will do int res equal to 0, and we can say switch field name. So in C# you can write a switch statement on strings. Okay, case. Okay, that's the first name. Well, let me make it F name. All right, first name is fine. First name. And now what will we do? res equal to this dot first name dot compare to st dot first name. So let me move this on the right. Okay, and then break. So as you can see, all we are doing is comparing the first name of the implied object. Remember, how was this being called? Let's go to the call. This was being called from the student sort helper, right? So it's being called through S1, correct? So anytime we use this keyword over there, it will be S1. This is being, the second student is being passed explicitly, and the sort field is being passed explicitly. So now we can go and say, if field name happens to be first name, then do this, right? Okay. So now all we have to do is just copy this for all the different fields. And so now let me change it to last name. Let me make it IDD. And I forgot to change this to last name. And last name. And this will be dot ID to st.id. Okay, and suppose this is called test 1, this is called test 2. Okay, so this dot test 1, test 2, test 1, and similarly test 2, test 2, test 2. Right? So once we are done with the comparison in this method, all we have to do is at the very end return res. Okay? So to summarize, in the student class we added one extra method called compare to, right? Which has nothing to do with any interface. We created it. Okay? And it takes two parameters, the student object. The other student object we are comparing to will be called through this method. Okay. And then whatever field we wanted to sort on. So all it does, writing a switch, it basically checks is somebody specified the field name to be first name. If so, compare the first name. If somebody specified the field name to sort on to be last name, then compare the last name, right? One by one, so it does that. Okay, now on purpose, because it's a string, somebody can put anything over there. So on purpose, I did not put ID, I put IDD, and I'll explain the reason in a second why. Okay, so in the student class, this method was added, extra method was added. And if you recall, our overall scheme is, in the project, we added one extra class called student sort helper, and this is the one that implemented Icomparer, right? Okay, and what's its job? What's the student sort helper's job? To collect the field name from the caller, what field they are interested in sorting on, right? Icomparer has the compare method. So somebody will give us the two objects they wanted to compare on. They will call it, they will pass us both explicitly. So meaning now the caller will call, okay, the caller will not call S1 dot compare to S1. So if they are using the Icomparer, then they will do compare. S1 comma S2. So this is how the caller will call, right? So anyway, once we receive the two objects, for example S1, S2, we convert them to a student, and then we delegate the work of the comparison based on the given field back to the student class, okay? So now let's test it. So if I double click on the form, if I go to the toolbox, double click on a button, and let me call this BTN's sort by comparer, and give it a text property of sort by comparer. Okay, so now if I double click on it, so now take a look over here. If I say stdlist.sort, okay, you will see the IntelliSense tells us there are 3 overloaded sort methods, right? The first one is without any parameter.